Hello and welcome to another presentation of Encache. Today we are going to be talking about how we can deploy Encache into a Service Fabric environment. There is a lot to cover, so let's get started. Let's start off with a general overview of what we are trying to achieve. So here we have a bird's eye view of a typical Service Fabric application deployed to Azure. We have a Service Fabric cluster that has an Azure load balancer. Within the Service Fabric application, we have a number of services that could be written in different languages. These services are typically deployed as containerized services. Now, in an enterprise application, distributed caching is important for enabling high read performance, and that is where Encache comes in. Encache can be deployed within the Service Fabric application as a containerized service. The Encache servers running within the containers on the multiple nodes of the virtual machine scale set can communicate with one another and form a clustered cache. Bridging the gap between the Encache clients and the servers, we have the Cache Discovery Service, which is used to get the real-time IP address information of the Encache servers and furnish that information to the Encache clients. With this information, the Encache clients can then create cache handles with which they can start performing cache management and CRUD operations on the Encache clustered cache. So the following are the main parameters of the demonstration we're going to have today. The Encache servers that are running within the Windows containers will be using the Docker image with the name of alachisoft/encache and a tag of latest. This contains the Encache Enterprise 5.0 SP2 edition with a .NET Framework installation. We will start off with two Encache servers that are brought together to form a clustered cache with a partition of replica topology. The two Encache client applications we have are written in .NET Core and Java, and they will perform CRUD operations on the Encache servers. So to get started, the first thing we will do is create a Service Fabric infrastructure on Azure. I can come over to my browser window where I have already opened my Azure portal. I have created a resource group with the name of Encache Service Fabric, and this at the moment contains only a single Key Vault resource. This Key Vault resource contains the certificate that will be used with the Service Fabric cluster. Coming over to Visual Studio 2019, I have an ARM template open and have introduced settings to allow for the Service Fabric Open Configuration mode. We will talk more about Service Fabric Open Configuration mode and why we are using it after we have deployed the infrastructure. So to get started with the deployment, I can come over to Solution Explorer, and on my Azure Resource Group project, I can right-click, come to Deploy, and I have listed the resource group. This will open a deployment window. I can click the deployment button and the deployment will start. This will take some time, so I'm going to pause the video here. Our template has been successfully deployed, and to confirm this, we can come back to our Azure portal. If I refresh the page, you will see changes. And here we do. So now our Service Fabric cluster and all the associated dependent resources have been successfully created. To get started, the first thing I'm going to talk about is the open configuration mode that I touched upon before. This article basically goes over the open configuration mode and why it is used. For our purposes, open configuration mode allows for the Encache servers that are running within the containers to actually be able to communicate across multiple hosts and come together to form a clustered cache. And to see how this is done, we can come to the Azure portal, and the first thing I will look at is the virtual network. Okay, so now we have multiple nodes from the virtual machine scale set, but if you look closely, each of the nodes has multiple IP addresses assigned to them. The first IP address is the primary address for the host. However, the other IP addresses that are attached to the node form the secondary IP address pool. And with the open configuration mode of Service Fabric, these IP addresses will be assigned to the containers on which the Encache servers will be running. With the IP addresses assigned from this secondary pool, the containers in the multiple hosts can communicate with each other seamlessly to create a cache cluster on Service Fabric. The other thing I want to look at in the resources is the load balancer. And if I come to the front end IP configuration, the rule I'm actually interested in is rule 10, and this has to do with the port 8251, which will be used by the Encache Web Manager that we will talk about later on in this presentation. But the important thing to note is that with the Encache Web Manager, we are going to be using a sticky persistence, as can be seen by the session persistence field shown here with a value of client IP. With this, if there are multiple instances of Encache Web Manager running, we will be able to have a consistent user experience between the browser and the end service. Now that we have looked at the infrastructure and deployed it successfully, we are going to go into the deployment of the Service Fabric application. And for that, we'll come back to Visual Studio. And we have a number of service manifest files corresponding to the services of the application. We have the Encache service, the Encache Web Manager service, the Encache Discovery service, as well as the client container service that will house our client applications. We will go into the details of each of these services after we have deployed the application. To do that, we come back to Solution Explorer. And over here, we'll just right click on the Service Fabric application project name, and coming down to publish, this will open up our deployment window. And as you can see, it has already picked up the Service Fabric cluster connection endpoint. All we have to do at this point is to click publish, and the process will start. This will take some time, so I'm going to pause my video here. The application was successfully deployed, and we are ready on the Service Fabric Explorer window. As you can see, the cluster DNS is given over here. And if I go and see at the dashboard, I have 5 nodes up and running with 1 application and 4 services. The 4 services can be seen in the left pane. The first service that I want to look at is the Encache service. This represents the Encache servers that will be running within the containers and which will form the clustered cache. Then I have the Encache Web Manager service. This represents an easy to use GUI for cache cluster creation and monitoring. Then I have the Encache Discovery service, which will be responsible for acquiring the IP addresses of the Encache servers and furnishing them to the client applications. Speaking of the client applications, we have the client container service, which represents a container that houses 2 different applications, one written in .NET Core and the other in Java. Now I will go into the details of each of these services in turn. The first one I want to look at is the Encache cluster service. And for that, I'm going to come back to Visual Studio. This is the service manifest for the Encache cluster service. As you can see, it is a container service that uses the image alachisoft/encache. There are a couple of endpoints that I register with the naming service, and these are as follows. We have the cache management endpoint that exposes the port 8250 on which the cache servers will be listening for connection requests. We have the cache client endpoint, which is exposing port 9800. All the CRUD operations are performed through this port. Besides these, we have the bridge management and the bridge client endpoints as well. For this present demonstration, we are only going to be concentrating on the first two endpoints shown over here. The second service that we look at is the Encache management service that represents the Web Manager GUI. Coming back to Visual Studio, if I come to the service manifest for the Encache Web Manager service, we see that it is also a container service that uses the same image as the Encache service. And the endpoint that we register with the naming service is web management, and which exposes port 8251. The third service is, of course, the Encache discovery service, and the service manifest for that is given here. The Encache discovery service is a stateless, reliable ASP.NET Core Web API which consults with the naming service and acquires the endpoints that were registered by the Encache service given here. With the endpoints received from the naming service, the discovery service can then furnish that information to the Encache clients. And the fourth service we have in our application is the client app services. And for that as well, we have the service manifest open, and the client applications, the .NET Core and the Java, are housed within the same container, the image of which is Encache apps with a tag of SF client. The important thing to note here is that with the Encache service and client service, we are using OpenConfig. The Encache service has the OpenConfig mode to allow for the containers running on different hosts to communicate with one another and thus form the cache cluster. While on the client container, we have a Encache client and installation, which will be used by Web Manager GUI to acquire the client-side counters and thus be able to monitor the client behavior from the GUI. The next part to do is the actual creation of the cache cluster. And for that, let's go back to our Service Fabric Explorer window. The first thing I'm going to do is confirm that my service discovery is working. For that, I will give in the URI, which is made up of the cluster DNS, and the port on which the discovery service is listening, which is 55100. If I click enter, I see that the IP addresses and the associated ports for each endpoint that were registered by the Encache service have been successfully presented. If you look closely, the IP addresses are the same as given by the virtual network to the Service Fabric nodes as part of the secondary IP pool. Now that we have the service discovery running, let's go and come to the Encache Web Manager. Again, we'll give in the cluster DNS followed by the port on which it is listening, which is 8251. And this brings us to the main window of the Web Manager GUI. Now I'm going to demonstrate how easy it is to create a clustered cache. And for that, all I need to do is click the new button shown here. I will start off by giving the name for the cache, keep everything else default. I will use the partition of replica topology with asynchronous mode. And now at this point, I'm going to give in the IP addresses of the servers that will make up my clustered cache. So first, I'm going to give in the first IP and the second one, 11. With these two added, we can come to the next phase, keep everything else default. And at the end, we just click finish and the cache will be created as can be seen on the main window. Now that it is created, it's time to start it. And for that, we can click the checkbox next to the name of the cache and then press the start button. Now that the cache has been started, there are a couple of things we can look at right now. The first thing we can do is look at the monitor tool by clicking on the monitor button while the checkbox is pressed. This will open another window and we will be able to see the dashboards that make up our monitoring tool. The first thing you can look at over here is the cluster health. We see that we have two servers with the active and replica partitions fully connected, as can be seen by the green color. We have the four different partitions shown in a graphical format here as well. There are a couple of counters we can look at right now, including the requests per second, the additions, fetches, updates, deletes, etc. The count is 0 along with all the other CRUD operation counters because there are no client processes connected as yet. And the client processes, once connected, can be seen from the client process dashboard, which will show the client IP, the process ID, and which server it is connected to. This is the server dashboard. The other dashboard that's available by default is the client dashboard. And here we can look at the different counters coming from the clients and be able to diagnose and monitor the client behavior. The third dashboard that comes by default is the report dashboard that shows an overall view of both the server and the client side performance counters. To see the information in action, we will now start the client applications. So now we get to running our client apps. Coming back to the monitor window, I have here the PowerShell open within the client container, and I'm already within the NetTester folder that contains the binaries for the .NET Core app. I will run a batch command that takes as parameters the name of the cache, which is demo cache, as well as the URI of the cache discovery service as shown over here. It's made up of the cluster DNS as well as the port of the cache discovery service. Now, if I press enter, the cache will be initialized from the client side and we will be looking at some activity on the monitoring window. So without further ado, and here we see that the client has been successful in getting the IP addresses and the cache handle has been initialized. And this can be confirmed from the cluster health monitor, which shows that the client counter number of clients has increased by 1. We also start seeing some activity on the different dashboards that is associated with the CRUD operations, such as the additions, fetches, updates, and deletes, as well as the overall activity being shown with the requests per second. We see that the count has started increasing as the client has started putting items into the cache. And we see in the client process new entries related to the client process. We see the client IP and the process IP ID. And we see that the client is connected to both servers. This is a feature specific to the partition and partition of replica topology, known as being cluster aware. Coming over to the client dashboard, we see some activity here as well. And we can see that the web manager has been able to get the counters from the client side. The report dashboard gives an overall view. We see that the per node instance of the performance counters are being shown here on the servers. And we also see activity on the client report side as well, coming from the client side. Now that we have been able to successfully connect from the .NET Core client, we'll now try to connect from the Java client as well. So just like with the .NET Core application, we have a batch file that runs the Java application here. Again, it takes the same parameters, namely the name of the cache as well as the URI of the cache discovery service. Now I will run the program and look at what changes in the monitoring window. So I press enter and the application has started. And it has been successfully initialized, and we see now that there are now two clients connected to each of these servers. Coming over here, let's look at what the activity is showing. First of all, let's look at the count. The count has started increasing because the number of clients has increased and they're both dumping data into the cache. The requests have started increasing as well, the rate of them. And over here in the client process, we see that there are two clients shown over here. Since they are running from the same container, the client IPs are the same, but the process IDs are different, and one coming from .NET Core and the other from Java. If I come over to the main window, another window I want to show is the statistics window, which gives another view of what's going on. To do that, I will click the ellipsis button and come over to the Show Statistics tab. And we see here the per node performance counters in this window as well. The IP addresses are shown here. So we have been successful in connecting our clients to our servers all within the same Service Fabric cluster. In this last part of the demonstration, we are going to demonstrate the runtime addition of nodes to the clustered cache, and we will see that addition has no impact on the performance of the client applications. For that, let's come back over to our main window in the Web Manager. To add a third node, all we have to do is click on the View Details link as shown over here. This will bring us to another window, and if we come to the Server Nodes section, to add a third node, all we have to do is click on the Add button shown here and give in the address of the third server. I will do that here, and I will give the one with 17. And the node was successfully added. Now that it's added, we have to start it. And for that, we just click the checkbox next to the IP address and click Start. And it has been successfully added. Coming back to the main window, if we refresh this button, we see now that there are 3 servers. And now let's look at what happens at the monitoring window. Same as before, we click the checkbox here and click on the Monitor tab. And now we see that there are 3 servers shown in the cluster health dashboard, and it's fully connected. And in the client process, we have 3 different servers furnishing the requests from the 2 clients. And if you look in the count section, the count has been load balanced among the 3 nodes. This shows that the load balancing strategy employed by the partition of replica cluster is in effect. This brings us to the end of our presentation. We have looked at how we can deploy Encache as a containerized service within a Service Fabric application. If you have any question about Encache or the presentation that you have just witnessed, please don't hesitate in contacting us at support@alachisoft.com. Thank you.